Good morning, 7th graders. We are on page 41. 41 today. I'm doing the homework from lesson 5. It says, what is the same about these two experiments? What is different? Hopefully, by looking at that, you notice that it has the same letters, L-A-M-B, L-A-M-B. Okay? So it had the same sample space. Same letters are possible in both of them. Okay, what is different? Okay, what is different? Well, in lamb, every letter has the same probability. It's 1 out of 4. In Alabama, there's one letter that's certainly more likely than the others. Okay, A is much more likely than the other letters. That is what's different. Here they're all the same. Here one letter has a better chance of getting picked. Problem number 2. Andre picks a block out of a bag 60 times and notes that 43 of them were green. What should Andre estimate for the probability? Well, based on his experiment, 43 out of the 60 were green, so that's going to have to be what his estimate is because it's based on his only experiment. Nobody else drew anything. Okay, Maya looks in the bag and sees that there's only 6 blocks in the bag. Should Andre change his estimate based on that information? Okay, should Andre change 6 blocks in the bag? Okay, so there's 6 blocks. Based on Andre's drawing, how many of those would you expect to be green? Okay, well, 1 out of 6 means if he did it 60 times, he'd get 10 green. 2 out of 6, if 2 out of the 6 were green, took it times 10, I'd get 20 out of 60. This would be 30 out of 60. This would have been 40 out of 60. So basically, which one is closest to his experiment? Okay, I would say 4 of them are probably green. 4 out of 6, if you do it 60 times, you should get around 40 green, which he is really close. So would he have to change his estimate? He could probably say 4 out of 6, or 2/3, based on what Maya saw in the bag. Okay, but 40 out of 60, if you draw 60 times, it's very unlikely you're going to get exactly 40. Okay, maybe somewhere between 35 and 45 would be a good guess, which is what Andre was in. So he wouldn't have to change, but he could be more accurate based on Maya peeking in the bag for him. Problem number 3, a person suspects a standard number cube of dice is not so standard. He rolls it 100 times and it lands on a 6 40 times. Another person rolls 100 times and it lands on 6 42 times. A third person rolls a 6 and it lands on a 6 33 times. Based on the results, is there evidence to prove that this cube is weighted? It's not a standard. Okay, so person 1, 40 out of 100. Person 2 got it 42 out of 100. And person 3 got it 33 out of 100. Okay. Now, how many times should it happen? Okay, should it happen? Well, it should happen 1 out of 6 times, right? 1 out of 6 times. If I take 1 divided by 6, you get 0.16 or 0.17. So it should happen about 17% of the time. So out of 100, 17% of the time, it should happen 17 out of 100 times, 17 hundredths. Okay, so would you suspect that this dice is weighted when it happened 40% of the time, 42% of the time, and a third of the time, 33% of the time? I would say yes. Those are all a lot higher than 17%. Even the lowest one is about double. Okay, so I would also be very suspectful of that dice. Okay, question 4. textbook has 428 pages numbered starting with number 1. You flip to a random page in a way that it is actually equally likely to stop at any of the pages, so 1 through 428. What is the sample space? Okay, you don't have to list them all because that'd be a lot, but everything from 1 to page 428 is the sample space. What's the probability of turning to page 45? Well, how many page 45s do I have in my book? 1. How many total pages do I have? 428. So not very likely that I will pick page 45. Problem C, what is the probability to turn to an even number page? Well, how many of those are even? 214 of them are even. Half of them, right? Half of them are even. So your probability is 1/2. Problem 5. Rectangular prism is cut along a diagonal on each face to create 2 triangular prisms. Distance from A to B is 5 inches. A to B. What is the surface area of the original rectangular prism? And how about the 2 triangles? So first one is a rectangle, then if I'd pull the triangles apart, I'm going to have more surface area, obviously, because you're going to have 2 shapes. And the middle would get counted on both of the triangles. So let's look at the original rectangular prism. Let's just figure out the area of every side of the original rectangle. The bottom here is 3 times 5. Top would be the same, that's 15, and 15 is 30. The front and back is 3 times 4. 3 times 4 is 12. Front and back would be 24. And then I have the sides, left and right. 5 times 4, 5 times 4, 20 times 2 is 40. Add them up. 4, 6, 9. That would be inches squared. Okay, so that answers the first question. Now, how about for the triangular prism? So we're just going to look at the first triangle here. I'm going to put the height of 4 there, same as the back. And I'm just going to concentrate on this piece right here. So, area of the base. I have a triangle. Here's my 90-degree angle. That means this is my base and height. 3 times 4 is 12. Divided by 2 is 6. So the area of the base is 6 on my triangles. And I have a front and a back. So that's why I have 2 of them. Plus the perimeter of the base. 3 plus 4 plus 5. 12 times the height. How far will this extend up if I set it on a triangle? And that would be 5. So 12 plus 60, and that is 72 per triangle. All right, if I break them apart, I'm going to have 2 triangles plus another 72, so I'm going to have 144 square inches. Now you might say, why is it so much more than the rectangular prism? And the reason is this middle piece right here. Doesn't get counted when it's one solid piece, but if I split it, I'm going to have that big piece on the left triangular prism, and the right triangular prism, so it gets counted twice. That's the reason it is so much higher. All right, guys, that concludes the homework for today. Continue to stay safe and healthy. We'll talk to you soon.